logics. In the previous class, we have discussed about the push button, right? We have discussed about the push button, active high, active low configurations. And in today's class, we are going to discuss about automatic lightning controller. Okay, we are going to discuss about automatic lightning controller. So based on the we are going to take LDR, which is light dependent resistor. Okay, and also we are going to take Arduino, and then we are going to take the LCD display. So based on the light that is falling on the resistor, that is LDR, it is going to show we are going to take the output, we are going to take the input from the LDR based on the intensity of the light that is going to fall on the LDR to the analog pin of our Arduino. Based on that particular input, we are going to display the corresponding digital value onto the LCD, and we are going to take the LEDs to indicate the different levels of intensity of light that is going to fall on the LDR. So this is the starting or the required information related to this lecture. So let us move into the video. First, before writing the code, you always need to just connect the connections. So I am going to make the connections first initially. Okay, see, first I am going to just a second. First we are going to take the Arduino. Okay, I have taken the Arduino, and then LCD display. You can see the LCD display as well. So I am going to zoom when the connections are being done. Okay, and I am going to take several number of LEDs like this. Okay, I have taken Arduino and then LCD display, and I have taken the LED. So, and I have taken a resistor whose value is 330 ohms. Okay, whose value is 330 ohms, and I have taken another resistor. This value is 330 ohms. Okay, you just change it. Okay, it is being 10k over here. You need to change the value over here. Okay, by double tapping on the resistor, you need to change it. So I am going to take the LED like this. Like this, I am going to take the LEDs and then resistors. Okay, have taken how many LEDs I have taken? I have taken total of 8 LEDs. Okay, and I have connected resistor 1 and 2 all the LEDs cathode terminal. Okay, I have connected resistor 1 and 2 all the LEDs cathode terminal. You can see. Okay, and other end of the resistor I have connected together. All the other ends I have connected together, and I have connected it to the ground terminal of the Arduino board. Now, next, what I have done is from 7th pin to 0th pin. Okay, it will be total 8 pins, right? So all the anodes of 8 LEDs are going to connect from 7th pin of Arduino to 0th pin of Arduino, like this. Like this I am going to connect. Okay, like this I am going to connect. Okay, all the anodes of the individual LEDs are connected to the 7th to 0th pin of Arduino, and then cathodes of LEDs are connected to the ground terminal of Arduino through resistor whose value is 330 ohm. Okay, whose value is 330 ohm. Okay, 330 ohm. Okay, the resistor value is 330 ohm. You just change it. Okay, now we have done our connections with the for the LEDs, right? Now we are going to do some other connections as well. Okay, next, now we are going to connect the connections from Arduino to LCD display. We have connected we are going to connect D4 to Yeah, we are going to connect D4 to D7 of LCD to D8 to D11 like this. Okay, we are going to connect D4 to D7 of LCD display to D 8th pin to 11th pin of Arduino. Like this we are going to connect the connections, and then next what we are going to do is we are going to connect the pin number 12 of LED to enable pin in the LCD. Okay, and then we are going to connect ground terminal of Arduino to RW, that is read or write bar. Okay, read or write bar, and we are going to connect 13th pin of LCD to RS. Okay, RS of, sorry, 13th pin of Arduino to RS of LCD. Now we have made our connections with the LCD as well. Okay, now what is left? We are going to left with LDR, right? So we are going to take, let me see what okay, I have taken the LDR. Okay, I have taken the LDR. How to take these components? You need to click on the plus symbol and you need to just enter the component name, then the component will be added to your workspace. Okay, next we have taken the LED. It is going to have total 4 pins. You can see the 4 pins of the LED. I am going to connect a resistor to analog pin of LDR. Okay, I am going to connect resistor to analog pin of LDR and other end of resistor to ground of Arduino. Next, I have taken the output from the analog A0. Okay, I have taken the output from input to the Arduino from the LDR pin A0, and I have connected that particular pin to A0 of Arduino. Next, I am going to connect ground terminal of LDR to ground terminal of Arduino. I am going to connect VCC to 5 volts. Okay, and I am going to just leave the D0 pin unconnected. Okay, floating. Okay, so now we have made our connections like this. Now we have made our circuit connections like this. Now we are going to write the code to make this circuit work as a automatic lightning controller. Okay, so let me discuss the code part as well. So let us discuss the code part as well. Okay, so the first line is hash include liquid crystal.h. Why we are going to use is because we are going to have an interface between the Arduino and then the LCD, right? So we need to use this liquid crystal.h header file to use the commands related to the LCD, or the commands or the functions related to the LCD display. Okay, next we are going to initialize the LEDs. Okay, total we are going to have 8 LEDs, right? Those 8 LEDs are connected to 0th pin of Arduino and till 7th pin of Arduino. From 0th pin to 7th pin we have connected 8 LEDs. Okay, so we are going to mention them as well. Int LED7 equal to 7. It means 7 is nothing but Arduino pin number. Arduino pin number is 7, right? We are going to give this pin number a variable, that is LED7. It means this LED is treated as LED7. Okay, next, and so on up to LED 0. Okay, from 7 to 0 there are total 8 LEDs. So we have declared all of them and we have given pin numbers from 7 to 0. Next, now this is the line liquid crystal LCD of 13, 12, 11, 10, 9, 8. What is the meaning of this particular line means? If you are going to see the connections to the LCD from the Arduino, then you can able to observe we have connected 13th pin, 12th pin and 11th pin and 10th pin and 9th pin and 8th pin to the LCD. Okay, it is nothing but this particular line tells that from Arduino we have used the pins 13, 12, 11, 10, 9, 8 to connect to the LCD display. So that we need to mention this particular line. Next, void setup. Void setup is nothing but it is a function. It is of type void. It is not going to return anything value. Okay, it is going to execute only one times after the program is after the simulation is started. After the simulation is started, the things or the statement that those are specified in the setup function are going to be executed only one time. Okay, put your setup code here to run once, only one time it is going to run. Okay, next, LCD dot begin of 16 comma 2 of LCD dot begin of 16 comma 2. The line meaning is nothing but we are going to use here 16 by 2 LED, that is 16 columns and 2 rows. Okay, this particular LED is containing 16 columns and 2 rows. Okay, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. Okay, we are going to have 16 columns and 2 rows, 1 and then 2. Okay, next, pin mode LED 0 comma output. Okay, we need these LEDs needed to be glow, right? These LEDs are the output devices, right? These are not going to give any input to the Arduino. These are taking output. These are taking input from the Arduino. It means from Arduino we are going to give the output, right? If we are going to apply or if you are going to send 5 volts supply from 7th pin of Arduino to LED, then this particular LED will be glowed, right? So that we are going to use 0 from 0 pin to 7th pin, we are going to use them as output pins. Okay, we are not going to use them as input pins, right? All the Arduino pins can be used as either input or either output as well. So in this case we are going to use them as output, not as an input, so that we have declared that pin mode LED 0 output. Since all these 8 LEDs are going to be used as a output pins, so we need to declare all the 8 pins as a 8 pins of Arduino as a output. Okay, see, we have declared all the 8 pins of Arduino as an output from LED 0 to LED 7. Okay, next, we have finished our setup, right? Now we are going to write the void loop function. Okay, void loop. Okay, since we have used void, it is not going to return anything, but the difference between setup function and loop function is setup function is going to execute only one time, whereas loop function is going to execute for unlimited time or continuously till the simulation stops. Okay, next, we need to put our main code here to run repeatedly. It is going to run repeatedly after once the simulation is started. Okay, int is a data type. We have declared a variable, that is LDR. Okay, we have declared the variable, that is LDR equal to analog read of A0. Analog read of A0. What does this line meaning? Means we are going to take the input from the LDR to the Arduino, or we are going to apply the input to the LDR from the Arduino. Obviously we are going to take the input from the LDR to the Arduino, right? Based on the light that is going to fall on the LDR, right? Actually we are going to take the input from the LDR to the Arduino, so that we must read the input from the LDR to the Arduino. For that there is a function. Total there are 2 functions. One is digital read and analog read. Since LDR is going to give the analog input, right? Analog input to the Arduino, we have using the analog read. And if we are going to see properly the connections, we have connected, we have taken the input, we are going to take the output from the sorry, that is we are going to take the input from the LDR through the A0 pin, so that analog read of A0, and we are going to store this value in a variable that is called as LDR. Next, int temp is equal to map of LDR comma 0 comma 10223 comma 0 comma 255. What does this line mean? This is nothing but we have taken the LDR, right? So this line, okay, this line is there, no, which is analog read. When we are going to store the value into the LDR, it is going to store in the 10-bit scale, so that from 0 to 1024, okay, it is going to store the value in 10-bit scale from 0 to 1023. But we don't need the 10-bit scale, we just enough the 8-bit scale. So that what we are going to do with the map function is, we are going to modify the scale of the LDR from 10-bit scale, that is 0 to 10223 to 0 to 255. It is nothing but this line is simply modifying the scale from 10 bit to 8 bit, that is range from 0 to 1023 to 0 to from 0 to 1023 to 0 to 255, from 10 bit scale to 8 bit scale. That's it. Okay, there is nothing to by heart. Okay, next, LCD dot set cursor of 0 comma 0. What does this line mean? This line mean is nothing but you just place your cursor at the starting position, that is at the first row and first column of LCD, or you start writing or printing the data onto the LCD from 0th column and 0th row. This is the place, right? This is the place where the 0th column and 0th row is set to be, right? Next, LCD dot print ACD value equal to, okay, from this location, that is 0th row and 0th column, you just print a data, that is ACD value equal to, just print a message, that is ACD value equal to. That's it. Again, next, LCD dot cursor of 0 comma 1. What does this line mean? This line mean that you now place your cursor at 0th column first row. 0th column 0th row will be this one, right? Whereas 0th column first row will be this one. Okay, now you place the value over here, and then next, what we are going to tell, that LCD dot print of temp. Okay, you just print the temp value. What is the temp value actually? Okay, temp value is actually the LDR value. What is the value of LDR? That is the analog read. Okay, the analog value which we have taken from the LDR, right? But what is the difference between the LDR and temp? LDR is in the 10-bit scale, whereas temp is in the 8-bit scale, right? We have converted the LDR which is in 10-bit scale to 8-bit scale and stored it in temp variable, so that we are going to print the temp, not the LDR. Instead of printing the LDR which is going to give the 10-bit scale, we need the 8-bit scale, right? So that we are going to use the temp, okay, in the print of the LCD print statement, in this print statement. Okay, next, we are going to apply some delay. Okay, why? Because it is needed to have some delay. Otherwise, if you are going to, there will be continuous fluctuation of variation, right? Why? Because though these sensors are analog sensors, they are very sensitive than compared to digital sensors, so that we need to give some delay. And then LCD dot clear, we need to clear, we are going to just refresh the LCD. Okay, and then next, now we are going to write the conditions. When does this LEDs are there, right? When does this LEDs are needed to be glowed? Okay, if LDR equal to 0, Okay, if LDR equal to 0, otherwise you can also use temp as well. Okay, if you can also use temp as well, okay, in place of LDR, but using LDR is better. Why? Because since we are going to take the input from the LDR and we have stored in the LDR, right? Sorry, yeah, we have stored in the LDR, right? So that it is better to use LDR only. But while printing, it is better to use temp. Why? Because if you are going to use the LDR, it is going to give you the 10-bit scale, but we actually need the 8-bit scale, right? So while printing the onto the LCD, it is better to use the temp variable. While while you are going to give the conditions to glow the LEDs, it is better to use the LDR. Okay. Next, whenever the LDR equal to 0, it means whenever there is no any light falling on the LDR, then what should happen is all the LEDs needed to be low. What is this digital right mean? Digital right in the sense, what is right mean? We are going, what is the right in terms of processor and memory? We are going to put some data into the memory, right? Similarly, in this case, what is this right digital right means all the pins from 0 to 7th pin are the digital pins, right? All the pins from 0 to 7th are digital pins. These pins can be used as either an input pins and output pins. Those things I have specified in this setup. I have specified all these pins as an output, right? Now we are going to use the digital write. What does this digital write means? We are going to send a low signal. Low signal is nothing but 0 volts or 0 logic 0 or 0 volts or logic 0. Okay, whenever you are going to send the 0 or logic 0 to all these LEDs, okay, all these LEDs to which terminal? Anode terminal, right? When you are going to send the 0 volts or 0 to anode terminals of all these LEDs, okay, then this LED will be turned off. It means it is not going to glow. Why? Because since cathode terminal is also connected to the ground, which is actually treated as a 0 volts, both the anode and cathode terminals are connected to the same potential, that is 0, so that these LEDs won't glow. Okay. Next, now we have specified what should happen when LDR equal to 0. Okay. Now we are going to write the on condition. When should these LEDs needed to be on and when should these LEDs needed to be off? If LDR is greater than 0, okay, if LDR is greater than 0, then what should happen is the LED 7 must be glow. Okay, the LED 7 must be glow. If LDR is greater than 32, I am going to take some random values. Since I have taken 8-bit scale, I have taken some random values. Okay, you can take any value that you require. Okay. Next, if LED is greater than 32, then what should happen is LED 6 to be high. And similarly, I am going to take all the condition for all the LEDs like this. Okay, till last LED. Okay, and you should remember a point, that is when LDR is greater than 32, both the LED 7 and LED 6 will be glowed. Why? Because if LDR is greater than 0, then LED 7 must be glow. If LDR is greater than 32, then indirectly it is meaning that LDR is obviously greater than 0, right? So that LED 7 and LED 6 will be glowed. For LDR greater than 224, LDR 0 will be glowed, and also along with LDR 0, LDR 1 to LDR 7 will be glowed or turned on. Okay, I hope you understand the point. Okay, next we have written on conditions for all the LEDs. Now what will be the off conditions? Simply opposite to these conditions, right? If LDR is less than 0, then LED 7 must be low. Simply the opposite conditions. Instead of greater than, you need to use the less than, and instead of high, you need to use the low. So like this you need to use it. Okay, we are going to use like this. Okay, till the last condition. Now we have completed our code. Okay, this is the complete code for the automatic lightning controller. Okay, with the help of the Arduino LCD and LEDs and LDR. So to run this code, what you guys need to do is you need to click on the start the simulation button. So now the ADC value is 62. Okay, whenever the ADC value is 62 right now, it is illuminance. Okay, it is illuminance, it is not luminance. Okay, it is opposite to the luminance. Okay, so you can see the ADC value is 1, so that only first LED is going to glow. Why? Because LED 7 needed to be glowed when LDR value is 0 greater than 0. So LDR value is greater than 0, so that LED 1 is only glowing. And whenever LDR value is greater than 32, LED 6 needed to be glowed. So, but here the LDR value is equal to 1, which is not greater than the 32, so that the LED 6 is not glowing. Okay, so let us, to change the luminance you need to click on the LDR. Okay, then a message will be pop up like this for you. Then you need to change the luminance. See, you observe the LED 6, it will glow after some point of time. While I am going to change this value, see, it is glowed. Okay, see, it is glowed. Okay, like this. Since you are going to decrease the illuminance, if you are going to decrease the illuminance, this is the illuminance. Since you are going to decrease the illuminance, then luminance will obviously will increase, right? So that all the LEDs are going to glow respectively like this. Okay, you can see the values. Okay, so let us do one thing. Instead of specifying the condition LDR in these conditions, let us use the temp. Okay, let us use the temp only. Let us see what happens. Now I have just replaced the LDR with temp. Okay, now let me rerun the code. Okay, for you. After saving the code, I am going to rerun the code. So for one, the LED one is LED 7. This is the LED 7, right? Why? Because we have connected it to the 7th pin, right? So this is the LED 7. So for one ADC value, the LED 7 is glowing. Okay, it is obeying our condition. Okay, next for 32, we need to have we need to have both LED 7 and LED 6 needed to be glowed. So I am going to change the luminance by clicking on the LDR illuminance. It is illuminance. If you are going to decrease the illuminance, obviously the luminance will be increased, right? So I am going to decreasing the illuminance, and you just observe the LED 6. It is going to glow at some point of time. Okay, it is glown. Okay, let me show you at what point it is going to glow. So at this particular illuminance, it is going to glow. Let us see the value. See, if you are going to see the value of ADC is 33, right? In condition what we have specified, when temp is greater than 32, LED 6 needed to be glow, right? 33 is obviously greater than 32, right? So that the LED 6 is glowing. Why the LED 7 is glowing? In the first condition, we have specified, that is when temp value is greater than 0, LED 7 needed to be glow, right? Here the ADC value is greater than 0, right? So that LED 7 is glowing. Okay, let us see the last condition. Okay, so for the last condition, you can see slowly, gradually, when I am going to decrease the illuminance, obviously I am going to increase the illuminance. When I am going to decrease the illuminance, it is indirectly mean that I am going to increase the luminance. When I am going to do that, all the LEDs slowly, gradually are increasing. Okay, are turning on, and you can see the last LED is turned on. When the last LED is turned on, when the value is 230. when the ADC value is 230. What is the condition that we have specified to turn on the last LED? That is 224, which is actually less than 230, right? Sorry, which is which is satisfied our condition, right? The temp is nothing but ADC value is 230. 230 is actually greater than 224, so that the LED 0 is glowing. Okay, like this we need to observe the output. This is nothing but the automatic lightning controller. I hope you guys understood this video. If you understood this particular lecture, I recommend you guys to go to the uh, walkway simulator in the online, and you just do the practice by your own. Then you are going to observe so many points related to this particular code. Okay, thank you, have a nice day.